TwinGate provides zero trust, identity based access to your cloud and on prem resources without the need for a pesky VPN.
Learn more about how TwinGate can help solve your remote access problems at the break.
Packet pushers.
Welcome to Day 2 DevOps, where the dev oops is in the details. I'm Ned Bellavance, and on Day 2 DevOps, we explore those details and how you can learn from the mistakes of others and build a solid DevOps practice on day 1 and beyond. Usually, on this journey of learning and doing, is my co-host Kyler Middleton, but sadly Kyler's feeling a little under the weather, so it's just going to be me today. But I'm not going to do this alone. I have a guest. Joel Krooswyk is the federal CTO at GitLab. Joel has extensive experience working with clients in the public sector and assisting with their unique needs and challenges. Got a lot of mainframes and legacy code that they're dealing with. Today's topic is all about applying AI to real-world problems and investigating the real-world results. The problem is refactoring your code. And we're going to talk about how AI can serve as a coach. It can serve as an accelerator, but it absolutely cannot do everything. So enjoy this conversation between me, Joel Krooswyk, federal CTO at GitLab. Well, Joel, welcome to Day 2 DevOps. To tee up this conversation, I was at the AWS Summit in DC, and I caught a presentation from you about using AI to help with modernization and migration. And at the time, I had noticed that almost every session had something to do with AI at the summit, and I was trying to ingest as much as possible. Your presentation stood out because it spoke to a real problem and a potential real solution. So, can you start by telling me a bit about the problem of refactoring code that companies and organizations are facing?
Yeah, thanks, Ned. It's awesome to be here. The problem that we're facing is that we're not facing the problem, quite honestly. The biggest issue we have is, hey, that thing's in the closet. Let's leave it there and not think about it. And hopefully that won't be a problem for us.
Hmm.
There's all this legacy code that's out there, and we're starting to run into some problems with some of it. And there's a lot of maintainer questions and scalability questions. And how do I stack AI on top of a legacy application, right? There's so many different things that are driving a conversation back to refactoring. And what I think is most interesting is just the way that with AI coming into our conversations, it's opening the door to some of those closets to say, well, let's take another look at this. Maybe we can do something with this. Maybe now's the time to reconsider it. So for sure, yeah, AI is waking up a new conversation around refactoring and reorganizing our applications.
Yeah, you mentioned legacy, and I know you work in the federal and public service sector. So when you say legacy, what's in your mind? What do you consider legacy from that perspective?
It's funny because clearly I've aged a little bit in technology, right? And so when I think about what that looks like, sometimes I look further back than I should. But for me, technology is changing so fast that it's anytime there's a major shift, we need to think of our aging technology and will it make the shift with us?
Hmm.
So case in point, coming into the AI world, we're going to have to think a little differently. Just like before that, we had to think about, well, I'm going into mobile development. Can I treat it the same way as the desktop app?
Hmm.
Or,
Yeah.
hey, here comes the internet. That's all HTML. Do I consider that the same way I have my heavyweight desktop applications to date? Of course, it revolutionized everything. So when we talk legacy in government applications, we can go back a lot further, right? We're talking about some languages that have been around since the 60s and applications that have been running almost as long, which is kind of mind-boggling. Some of the applications running are older than I am. But at the same time, I have to look at it from the perspective of simply, does the technology, does the process, does all this stuff apply where we are right now in meeting what the users are looking for?
Gotcha. So we identify there's some applications that might need some refactoring, some modernization. What are some common approaches to dealing with that before the era of AI?
Well, let me start with I've done a lot of research on this, right? I've done some refactoring in my life, writing a lot of code, but I did some research on this just to find out like how big of an irritant is this to the current development world? And hey, it's a clear number one.
Hmm. Wow.
There are more acronyms of BPOS and WTF and all the other things that go along with what did somebody do in this code? And so as I started reading through some of the forums and seeing just how big an irritant it is, I said, well, what are we doing today? And the answer is, well, we're refactoring our apps every day and doing that a little bit at a time so that we don't have to do the large scale refactoring. Because if we do, now we're talking about things like, well, I'm going to have to look at some new methods, maybe red green methods or extract methods or composing methods, these things that get us into large scale refactoring efforts. And as soon as you get into all those weeds and you start looking at things from that perspective, you know it's a major project. We're going to be here a while. And we're trying desperately to avoid that
Mhm.
as long as the application today isn't sitting in maintenance mode someplace.
I see. So we're thinking about newer applications, more modern applications that maybe have adopted a DevOps mindset and sort of this rapid iteration. They're constantly being refactored in a way that will keep
Mhm.
them adaptable and malleable for the future. But if you look back at some of those older applications, those heavy desktop applications that used Visual Basic or something going further back, whether it's Fortran, I don't know if that could even run on the desktop or Pascal or something like that.
Yeah.
Is it possible to modernize those applications? Because you can't use the same approach.
Well, and we can keep going further back, right? I mean, we can take Fortran and we can keep going further back into C from the 70s and Ada and COBOL and all these old languages. And so, yeah, I think we can refactor those. We can give a lot of thought to how those work and what we're going to do next in those spaces. And I think the further we go back, it's starting to be more and more critical. And what I mean by that is just if you think about just the last few years, for instance, right? We came through a pretty interesting global environment with people staying home and not being able to go out. So the virtual world sprang to a new scale of life that we didn't necessarily expect. And some of those legacy applications said no.
Mhm.
Just plain and simple. So what did we do? We called every developer we could find out of retirement, said, help us fix this code. It's old, but you might know how it works.
Right.
Well, fast forward now several years, some of those folks are no longer with us, plain and simple. We can't call them back. So, what do we do with some of these old languages that are starting to be harder and harder to maintain? And I think the answer is we're going to have to look into refactoring some of those legacy giant applications, and the heavier they are, the harder it is to prioritize updating them because this could be a year-long effort or more, depending on what the application is. So knowing that we got all that work in front of us, again, AI hopefully can help with some of this because otherwise we're going to need a lot more developers too.
Right. When I think about some of the migration projects that I've been part of in the past, it was always okay, we're going to lift and shift this application to get it up to the cloud or to a new platform, whatever it is. And then we'll rewrite the application later. We'll refactor it later. And later never seems to come. Has that been your experience being out there and seeing what folks are doing?
You know, it's interesting. Lift and shift, I've kind of retermed that. Anything that's left being lift and shifted is probably lift and dumped up to the cloud, right? We're no
Right.
longer shifting, we're just dumping it.
Right.
The problem we have, of course, is once those legacy applications get up there, the compute costs get astronomical, right? They're just not efficient enough to run in those environments well. So if you're not moving it into microservices, or if it's not got a scalability capability to it, it's sitting there idle, draining a lot of compute. And so the costs are too high. And I think that's going to be the next driver of some of this, right? Okay, the application doesn't scale the way I want it to, and now it's trying to drive my costs up in a new environment. I just got it out of one cost center. Now I've added another. Not ideal.
No, no, and it's funny, when I was walking through the expo hall, I saw at least 2 companies that specialize in mainframe emulation in the cloud, and I'm thinking, "That is amazing they can do that. That is really cool. That has to be so expensive. There's no way that makes sense."
But to your point, it would be the shortcut, right? Versus trying to get all this stuff rewritten. I get it.
And like you said, finding someone who understands that older language that it was programmed in and the way it was created can be really difficult. So maybe that
Yeah.
turns to how can AI assist with the refactoring process? And what ways can it help?
Well, there's a lot that AI does today. So let's start there. I'm not going to overpromise on something here, but just looking across the industry, I mean, it's pretty easy to see, right? What's being touted today? Almost every vendor seems to have some sort of code assistance, code completion. So, that's the easy one. And clearly that's making a lot of headways. We're seeing a lot of initial reports of once you start using this and people get used to it, it's pretty easy to pick up 30, 40, 50% efficiency efficiencies across a development organization. Now, is that a universal stat? Absolutely not.
Hmm.
But it seems to be some of the average that I'm seeing out there across the industry. That's helpful.
What do those percentages mean when we're talking about an increase in operational efficiency? Does that mean more lines of code being written, code being generated faster, faster releases? Like what goes into that percentage?
9 times out of 10, that's what it means is more code, like your first answer, right? We're generating more code that's going into our pipelines. Now, I'll caveat that with some of these metrics and some of them don't, right? Some of them take into account how many of the suggestions by AI are being accepted. And to me, that's one of the critical metrics. It's not about necessarily are you cranking out more code? It's are you cranking out code that's acceptable to us who know how to code?
Hmm.
Is it acceptable for, security violations, testable quality in the application? Like, what are we generating here? Is it any good? And so, when you look at these numbers, you have to take that into account of, okay, how much of that is or is not. This is from me just kind of doing a brief survey across a lot of different tool sets to figure out where we are. And that seems to be the number that comes up the most often is roughly a 50% gain. We have to dig deeper on that, to your point.
Right, right. To see what actually goes into that gain. And is it making the application more efficient and better? Or do we just have 1,000 lines of code where it could have been 500 with a more advanced or senior programmer at the helm?
Yeah, exactly right. And that's what we got to watch for, right? If we're doing, especially once we get into refactoring, if we're not taking lines of code out, we're going the wrong direction. We need better sustainability of our code base. So I think that's the other thing too, is we talk about code assist right away, but code assist in a vacuum is a huge problem
Hmm.
because we're just generating tons of code. And when you throw more code at the wall, eventually you hit a new silo. You hit a new problem in your development environment where things back up. Maybe we can't secure it fast enough. We can't test it fast enough. We can't deploy it fast enough. Something is going to be needed there. So when we talk about where we are with AI, it's really important to go, okay, I can generate a lot of code, but are we using the features like automatic unit test creation?
Hmm.
Are we creating any kind of automatic documentation that is like a pseudo comment mechanism basically for code? Are we doing anything with automated remediation of vulnerabilities? Like some of those things do exist today. Are we taking advantage of them all at once versus saying, I'm just going to grab some new code from AI and throw it into the system?
One of the things that I really like about the code assistant that I use, I was recently contributing to a Terraform provider, and writing the unit tests was taking 10 times longer than writing the actual code. And so I asked the AI assistant to help me write those unit tests. And did it get 100% right? No, but it gave me the basic framework and layout for the tests. And then I was able to fill in some blanks there, make a few edits. I think it made the process faster, but I don't have a ton of data to kind of reference against that. I think we need more widespread studies that are not just anecdotal in nature.
Yeah, absolutely. I got to say, it's one of the things that I really appreciate about what we're trying to do at GitLab is we're also generating some impact analytics. So the whole idea of, hey, you're using this, is it helping? And so we want to have that. And it's very difficult. It's not an easy thing for us to measure, but we're trying
Right.
and we're taking some different approaches to that. And I would love to see more of that across the industry to say, hey, this is how much code you accepted from AI. These are the features you're using. Here's how it's helping. Here's how it's accelerating things. And here's how it's literally getting people back to work that matters, doing the things that they love to do versus all the noise that they're typically mired in.
The idea behind AI is to kind of take away the repetitive, undifferentiated, heavy lifting portions of writing software and get you back to the more interesting part, which is like figuring out logic conundrums and mapping out the architecture of your application and maybe checking out that new feature that just appeared in one of the cloud providers, not just writing unit tests. It's not fun.
No, no, it's not. The parallel to that I heard recently is I want AI to generate solutions to wash my dishes and vacuum my floors, not free up my time so that I can do it. That's not how this is supposed to work. And I thought, oh, that is a perfect parallel to what we're talking about.
Yeah, absolutely. So, with that in mind, what are some other gotchas or pitfalls that you've seen for folks that are starting to use these AI assistants to rewrite their code?
I think the engagement is number one. So when you go to talk with AI, it's conversational, right? And so just like in conversation with people, if you leave context out, communication breaks down. And that's kind of a miserable place to be when you're having communication with somebody and you text something real quick and they, what did you just say to me? I left out a phrase. Sorry. AI works the same way. If we don't give it the full context of things, we get bad information back or we get a biased information back that just plain doesn't work. So I think, thing one is that conversation and the context. The other is specificity. So depending how detailed we are, the less detail we provide, the more chance that we're going to get this oddball variation in our non-deterministic output. And what I mean by that is I can ask the same question 6 times to AI and I may get a different answer all 6 times. So imagine if you now don't have enough specificity in your ask, those things get a lot bigger range to them as far as what answers come back. And so while there might be one solution that you're looking for to the problem, there may be 3, 5, 6 different answers that could solve the problem. So case in point, when I'm prompting AI for something, a lot of times I'm not going to ask it just to respond because it'll give me that one answer. I'm a keyword search guy. Put me back in the 90s, right? Like that's how I kept my career going is I'm really good at searches. So give me 5 answers. Give me 3 different possible solutions to this problem. That's what my prompt looks like. Don't tell me how to solve it. Give me 3 different ways to solve it and let me choose the best one. I think some of those things are really, really critical as we get into this space. And then, of course, we have to validate everything. I know for a long time I've heard trust but verify in software development. We are completely inverse right now. Verify what came out, then trust it. We cannot put the typical application of trust but verify on AI just yet. It's helpful.
It's like that over enthusiastic junior programmer who wants to impress you, but doesn't maybe know where all the sharp edges are yet. So you need to verify before you trust, I guess.
Absolutely, absolutely. Hey, by the way, to that point, I just read an article recently that was talking about how the junior developer or somebody who's earlier in their career is actually able to use some of the AI outputs as a coaching mechanism to help drive their career forward. I found that as a fascinating use case in all this because when we're talking about learning applications or refactoring applications maybe into something we don't know, AI can really help us as a coach. I hadn't thought of it that way until recently, so I'm glad you brought that up.
Knock, knock.
Who's there?
VPN.
VPN who?
Thanks for letting me in and giving me access to all your stuff.
What?
Kyler, did you know that when you grant someone access through a VPN, you're basically giving them access to everything behind the firewall? That seems bad.
You know what would be better?
What?
Granting someone granular access to resources based on an identity and their security posture.
Yeah. And maybe instead of having a single VPN concentrator, you could distribute access points to where they're needed across the clouds and on prem.
Oh, and make it outbound only so you don't have to open any pesky ports?
Yes, I could connect to my VPC resources, my Kubernetes clusters, or anything else behind a firewall.
That sounds amazing. It sounds like Twingate. I only wish we could deploy it with Terraform because Ned and I love Terraform.
But Kyler, have I got news for you? You can automate TwinGate with Terraform, Pulumi, or their public facing API.
I wouldn't leave my fate to any other company, and neither should you. Try Twingate now for free for up to 5 users or start a 14-day business trial at twingate.com.
One of the concerns that I've heard from the audience and in conversations is that because AI creates what sort of a junior engineer might create, it's going to push those junior engineers out. It's going to remove the need for them. So there's a concern that because you can't get a senior engineer unless you have a junior engineer first, and if we're not training our junior engineers, then there's going to be no senior engineers in 10 years. You flip that on its head a little bit. Instead of that, it's hire the junior engineer, but give them a bit of a coach that's going to help them and is far more patient than any human being I've ever met.
Absolutely. I think it has an interesting implication for all levels of development. I have been around code for a long time. I've got hundreds of thousands of lines of code tucked away someplace that I probably don't want to pull out of the closet, right? Just to be honest. But I know I wasn't the most efficient coder. And so for me to have somebody that's kind of riding alongside of me, right? Like if there's going to be an impact on something, maybe it's paired programming as the impact where I now have a digital assist. I don't know. But the reality is I can tell an AI engine question what level to communicate with me. Hey, I'm a 100, 200, 300, 400 to use an educational type of bent, right? Like, hey, I'm a 400 level student here. Don't talk to me like I don't know what I'm doing. Sync with me at this level and let's go. And I think that's really good. Looking back, I would love to have something like that to help me make more efficient code, even though I'd been coding a long time. Meanwhile, if I'm fresh in my career, I've actually seen where explain this code to me like I'm 5 works as an AI prompt. So I'm really excited to see that too of like, well, I don't know what I'm doing here. Explain this to me like I'm 5 and off we go.
As someone who has written code and gone back 6 months later and being like, "Man, I really should have commented that because I have no idea what that's doing." I can see using one of these assistants to, "Okay, tell me what that code is doing and then add a comment for me." That would be awesome because otherwise I'm gonna come back 6 months after that and still have no idea what that line of code is doing.
Yeah, and to pull us out of development for just a second, that's the number one ask that I get from the executives saying, hey, our problems are over time. Developers come and go, whole teams come and go,
Sure.
applications go maintenance mode, we move on. I now need to go fix something. How do I do that? So that's the ask that I get all the time is, what can AI do to explain this code to me? Because there are no comments, or the comments are, this code works well, don't touch it.
Never seen that. But
No.
interesting. So, one interesting thing that I read recently is that DARPA has decided that they're going to move all of their C based applications to Rust. I think they're calling it Tractor. Is that right?
That's right.
It's definitely an acronym for something relating C to Rust, but I don't remember what it is. How do you foresee AI impacting that? Are they going to be allowed to use AI for that?
Actually, they're looking at AI as one of the key accelerators for that. So, what they're actually doing is testing right now, pumping C code into AI engines and seeing what comes back. And they're saying, yeah, it works. It's not there yet. We got some work to do because, of course, it's contextual, right? We're not going to know methods. We're not going to know things to call within a certain language that is going to translate to another directly. So, all those little transient gotchas are still in the way. But that is exactly the use case that they're looking at is moving all their C code over to Rust and setting an example. And that's coming out of this most recent open source security summary from the White House just recently. And once they had the findings in hand of kind of how much open source is being generated in non-memory safe languages and all those kind of topics, well, then DARPA's gotten one of these initiatives to convert things. And they said, let's just take out C. This thing's 50 years old. Same problems keep coming back to us. So I see it as incredibly ambitious. I will be following along closely, though, to see how they do in this.
Yeah, absolutely. I mean, it's interesting to note that the CrowdStrike debacle all involved the C programming language as well. And I think it was some memory unsafe operation that actually brought, what, 8.5 million Windows devices to a screeching halt.
Yeah, it was literally 20 inputs expected, 21 received. Boom, we went out of bounds and nothing could handle that error. So, down we went.
Oh, that's rough. Is there any history of successfully using an AI assistant to do that transition from C to Rust? Has anybody already done this successfully?
There's a handful out there that have actually done this, and I've got one favorite story about this, and it's something that dates back again to the pandemic era where the system was overloaded, too many users hit it at once, and it just slowed to a crawl. I don't know that it fully crashed, but it was almost non-functional. I actually followed a lot of applications back in that era just to see how things were performing, and there was some interesting stuff, wasn't there?
Yeah.
So that drove one of these use cases where somebody said, we have got to get this refactor. We can't let that happen again. They took a legacy C application, a monolithic application that was running in a data center, and said, let's port this to microservices. It should solve our problem. So they moved it to the cloud, moved it into microservices. They're utilizing Lambda and AWS for this particular example, ported that code from C to Rust. And within 6 weeks, this thing was running in its new place, which is pretty stellar for a decent size application. AI accelerated that refactoring. It was done very iteratively, no more than 100 lines of code or so at a time, function by function or just segment by segment. So very iterative, but very rapidly, this thing was migrated. And as a result, you end up with the same application running. So, it looks the same on the user side, but you've only got 10% of the code base left because of the inefficiencies of C compared to how Rust can be written written, especially across microservices platform. Now you're down to just 10% of the code base. So far easier to maintain. It would scale 50 times further because, hey, thank you to the auto scaling cloud. And then at that scale where it can scale up to, it can now run 100 times faster than the old application, which was all bogged down. So, I mean, it's a really good story. There's several stories like that out there, but that's got to be my favorite one so far. And interestingly enough, when you hear about a story like that in some environments already, they're going, yeah, we did this. It was okay. And I have to pause the conversation and go, wait a minute. You did what and how long and what was the outcome, right? So I think we're going to hear more stories like that as we go because there's so many different evaluations and experiments happening right now to see, hey, what can we do with this?
Right, right. So if we think about like the current state of what AI is capable of helping us with today, what do you think are like the top two or three use cases for AI in refactoring code today?
Mainframe, mainframe, mainframe. I think that's where we see the most. So today, what's interesting is if you think about the mainframe applications and you look back at like some of the code that's running there, you've got some pretty old stuff. You've got some pretty old languages running there, and we talked about some of them already. The reality is we don't have people that know how to maintain that. The mainframe costs are very high. And so we're trying to figure out how do we move out of those environments into something new. And so what that looks like is one of many things, but you can do things like I'm going to move from, say, COBOL into Java, right? That's just a pretty standard path, or an assembly into Java. We got old SAS code for statistical analysis. We need to get that into Python. We're going to move out of legacy language into C sharp. I'm hearing all those scenarios, quite honestly. And that is one of the number one considerations. And it's not how do I get out of the mainframe? It's how do I jump from the mainframe to the cloud and create new efficiencies at the same time? So this is like a big jump, right? We're not bringing it into our own data centers or anything. We're just making that leap. Ordinarily, if you're going to do this, you might outsource it. I've met a number of folks who do this today who do that refactoring. Now, AI is going to accelerate it for them, but it's also got people asking questions like, can I bring this in house? How much of it do you think we could do ourselves? Is it possible if AI gives us the assist? So I think that's the primary use case. There's a second one, and the second one really revolves around embedded. With all the problems we're having with automotive and with industrial controls, critical infrastructure in general being threatened, there's this kind of wait a minute. Some of the code that we write today, I can't secure. I've got old Ada code. I don't have a security scanner for that. What do we do? I'm running assembly or I'm running embedded C, and I've got memory safety issues. This is hackable stuff. What do we do? And so as we get into those environments too, we're starting to see a lot of that ported over. Rust keeps coming up in those environments very regularly. Last I saw, I think Rust was kind of, in the top 20 programming languages. If we keep going at the rate we're going, it's going to be in the top 5 over the next 5 years. There's so many people saying, we should probably just move to Rust. I just have to hope everybody doesn't turn off the memory management when they do unintentionally.
Right. It does seem to come up in more and more conversations. And the fact that you mentioned a concrete example of an organization that did that migration from C to Rust and did it very rapidly. I mean, I've been involved in a lot of projects, and 6 weeks is crazy. That is crazy fast. Maybe they didn't realize how fast that was because that's the first transformation they've done. And they're like, oh, it went so easily. As someone who's been bogged down in like 18-month, 24-month engagements, 6 weeks is insane.
Yes.
Wow.
Yeah.
That really makes me perk up my ears and go, okay, there might be something here.
I suspect too. I mean, if you think about that, I suspect there was a linearity to that code that allowed it to go that fast. Let's face it, like if you've got a lot of transient dependencies, a lot of open source calls, whatever, like this is going to get harder. But there are a lot of cases where we haven't looked at something in a while, and this may, yeah, get us down to that shorter time window.
Yeah, and if nothing else, the what you were bringing up where you ask AI to tell me what this code does, if you can't find someone who knows Pascal, who knows COBOL, and you have COBOL code running, you can now have AI at least explain what this application is actually doing in the background, and then you can rewrite that logic in another language that's a little more modern and that more people know and can maintain.
Yeah, absolutely. It goes to the point of test driven development being such a core part of refactoring, right? So we know what the application does. We know what we want the application to do. We can use the tests at the outset, but AI is developing the unit tests at the back end of its own development. And so if it's doing it right, it should come back around and align to what we set up for test driven development at the front end, right? Theoretically. And I think the interesting thing about the code explanation piece is just there are so many ways to do it. I always thought of it as, up until recently anyway, is like, okay, you'll tell me how it works and I'll interpret that somehow. Put that burden on AI as well. Hey, interpret this for me. I know Python. I don't know this code. Can you explain it to me like how I'd write it in Python? Oh, I get it now. Or break it down for me again at this level or that level. Help me understand this in the context of X, whatever that is. As soon as you set that up, it really creates a better level of communication between you and the AI engine so that you can get more out of it. And it's just something I woke up to recently of, don't just use the command as written, add your context, and wow, is it amazing how it changes the response.
And I love the adding options. Give me 3 different ways to do
Yeah.
this or 4 different ways to do this so I can cherry pick. Like if you go to Stack Overflow, that's what you find. You find multiple people responding with different legitimate answers depending on your context, and you select the one that works for you.
Yeah.
This is all like current day. You can do this today. What do you foresee the future looking like? What can we do tomorrow with these AI tools?
It's an interesting question because I think a lot of us are like, I really don't want to know. I fear it. I don't want to know. I'm going to be out of a job. And, my son asks those questions. He's in college right now. He's studying, his information systems degree. He's learning all these languages. Do I need this? Yeah, you need this. You need this badly. What we're seeing is autonomy from generative AI. And what I mean by that is the next leg of this journey is going to be the automation of some of the things that today we have to tell it to do. So think of it from the perspective of I've got a greenfield project. I'm about to develop some new code. I know what I want. So instead of going in and saying, hey, I'm going to create a project, we'll create a backlog, I'm going to start my code base, we'll create a repo, we'll set up our workflows and maybe a Kanban style or something, right? We just tell AI what we want. And based on how we've worked in the past, it's going to look at who is involved, what teams can do what, et cetera, and say, okay, here's what I'm going to do. I'm going to create the project for you. I know you want to get this deployed on Kubernetes and I want it to go to this cloud, and I'm just going to do everything on your behalf. Now, building this application based on how you built the last one, what I'm going to do is establish a backlog for you, and I'm going to potentially even play to the strengths of your team and make sure that your team and other teams that need to be involved are aware of it. I'm going to take a first crack at the code and write it for you. I'll do the unit tests as well. And then the first time you actually enter this project is after the first merge of the code is complete.
Hmm.
And now you've got a chance to validate it and look at it and see if we're on the right track. I would love to say that's made up. It's not. It's a direction that we're actually going. And so I can say that from the perspective of actually seeing this firsthand as the direction we're going. Now, it sounds like a little bit like replacement type of approach, right? The reality is, this is just kind of a Kickstarter program. It's the ability to use AI to say, hey, what do you know? How can you help us not get mired down in all this stuff that we have to do? I mean, how long does it take to set up a project? Sometimes it's easy, sometimes it's not. Depends if you got templates, depends who's on the team. Is it a new team? Tons of questions. With AI's autonomous approach to things, though, it should get us to a point where we've got a great Kickstarter for any new project. Same thing on the refactoring side. The project can kick off. It can take a first stab at things and see how far we get before we need to pull in the humans. Is it actually going to take care of everything? No. Because if you take a giant application and say, hey, refactor this for me, I'll be back in a while and check on you. I don't know what you're going to get, right? You shove a 40-page document in, it'll give you a great summary. AI is great at that. But when it comes to logic, operations, and code, you don't go shoving, hundreds of lines of code in and expecting a great output at the same time. So everything's got to be tempered with our enthusiasm. But I think that autonomous word is the one to watch for over the next year.
One of the challenging things is writing good automation and automating your workflows. It's a thankless task. You know it's going to save you time in the long run, but it's going to take up a bunch of time in the short run that you may not have. So the idea that maybe something can take over and just kind of help with automating the boring stuff, creating a project, setting up access, delivering the template, writing all the baseline stuff in the code, creating the files, like that seems pretty useful. But yeah, I agree. it's not going to be able to write the entire application for you. There's still a place for you as a developer or as an operations person to be involved in this whole process.
Yeah, absolutely. I see that this is, again, an enhancer. I really look at what AI is doing and where we're going with it as that ability to give us the interesting work, give us the challenge, give us the innovation stuff. Let us be creative with what we're doing. And you've probably heard that before. But the reality is, if we can take some of that other stuff out of the way, I mean, we've done our surveys here at GitLab, and developers continue to tell us year after year after year after year, about a quarter of my time is spent coding. Well, I don't know about you. When I get coding and I'm in the zone, like I'll go all night sometimes because it's just, oh man, and I look up and like, whoa, where'd the sun go? Right. And it's 1 a.m. Like I love being in the zone. I love solving that problem. And if we get to do things like that more often, then we're not stuck in meetings talking about workflows. I'm okay with that. That sounds great. Get me there.
Yeah. Oh, and I think that is just the perfect note to write out on. AI, if we do it right, is there to remove the boring stuff so you can do the creative and just life enhancing work. Like when you're doing something and it's creative and it's interesting and it's engaging you, that is fantastic. That's the ideal scenario. Get rid of the drudgery, let you get back to doing the fun stuff for whatever fun is for you.
Absolutely. Whatever fun is for you. I like that. It makes me think about like if I'm refactoring code or so. I love learning a new language or getting a new challenge, but I would love to have the help on that. The reality is, if you want to talk about what's fun for me, let me enjoy my day and then get in the kayak and go. That's what I would love to do. Help me get there. Then AI, you're in my good graces.
Fantastic. Well, let's get you on that kayak and out paddling around.
Sounds good.
Joel, if people want to learn more about you or some of the things you've talked about today, where are some good places to look?
Well, there's a number of places. The place you'll find me most active is every single day on LinkedIn. I've got a post on software development, on AI, on policy, or on something related. So that is the number one place to find me. Look me up on LinkedIn and follow along. I'd love to have you there. Love to interact with you there. And then, of course, there's a number of alternate podcasts and other events that I've done in the past. And the majority of those you can find on YouTube. Just search my name.
Okay, we will include that all in the show notes. Joe, thank you so much for being a guest today on Day 2 DevOps.
Thanks, Ned. This has been great.
And hey, listener, virtual high fives to you for tuning in. If you have suggestions for future shows, we would love to hear them. You can hit us up on LinkedIn or send some feedback via packetpushers.net/follow-up. You can find me, Ned Bellavance, at nedinthecloud.com, and my amazing co-host who couldn't be here today, Kyler Middleton. She's blogging over on Substack, and we're both very active on LinkedIn. Stop by, say hi. And hey, vendors out there, do you have a way cool cloud product you want to share with our audience of IT professionals? You could become a Day 2 DevOps sponsor. You'll reach several thousand listeners, all of whom have problems to solve. Maybe your product fixes their problem, but they'll never know unless you tell them about your amazing solution. You can find out more at packetpushers.net/sponsorship. Until next time, just remember that doing DevOps is awesome, and so are you.